Hello everyone. In this video I will continue with the last example in section 8.1. But before I continue, let me go over the previous question and let me make a correction. In the sample solutions here, I think I made a mistake, but let me pick the correct color first. Okay. Now, if you look at this part, right, it's coming here, but it cannot go that way because it is against this one. So I need to erase this part. And over here in this region, it should go this way, right? So this is our sample solution. And here, what are the sample solutions coming here and passing vertically here, so horizontally here, and then this way, right? So these are the some sample solutions, okay? Sorry for the confusion. Let me go to the next example. Find the linearization of the system at all critical points and classify the critical points. Okay, let's find the critical points first of all. Let me wait a second. So, okay. Remember, to get the critical points, we have set f of x. Okay, I have to change my color. F of xy equals 0, right? F of xy is y, so set it equal to 0. So we get y is equal to 0. And from second one, g of xy, which is this guy, right? G of xy, which is negative x plus 1 minus x squared y is equal to 0. And so from there I get x equals, if I move this negative x over the side, 1 minus x squared y. And from there I can get, so which x values or y values makes this happen? First of all, from the first equation, I have y is equal to 0, right? So I have to pick y is equal to 0 anyway. So if you plug in y is equal to 0 here, it will cancel out everything. So we will get x is equal to 0, right? That's the only possibility to make both f and g equal to 0, right? To make f equal to 0, y should be 0 for sure. If y is 0, if I plug in y 0 here in the g, I have to make also g equal to 0. To do so, I have to make x equal to 0. So we have only one critical point, 0, 0. Okay. All right, let's find Jacobian at any x, y. Remember, it is partial derivative of f with respect to x, partial derivative of f with respect to y, partial derivative of g with respect to x, and a partial derivative of g with respect to y. And what's the partial derivative of f with respect to x? It's just 0, right? F of x y is y, right? Derivative of y with respect to x, 0. And partial derivative of f with respect to y is 1. Partial derivative of g with respect to x is, let's see, negative 1 from this part, right? And what's the derivative of this part? Negative 2xy. So negative 2xy. And the derivative of g with respect to y, maybe I can write one little bit further here. And derivative of g with respect to y will be, so this part will be 0, and this part will be 1 minus x squared. Okay. So what is the Jacobian at 0, 0, right? This is our Jacobian to worry. If you just plug in 0 and 0 in the Jacobian, it will be 0, 1. So this part will be 0, so negative 1, and this part will be 1. Okay, cool. So, okay, this is the Jacobian. So what is the linearization then? U hat equals Jacobian times U. Maybe I can write that way. Jacobian times u. You had prime, sorry. Jacobian times u, which is 0, 1, negative 1, 1 times uv, right? And what is u? U is x minus x star. X star is the x coordinate of the critical point, which is 0. So u is equal to x and v is equal to y minus y star, which is again y, because y star is 0. Okay, after getting that, this is linearization. Okay, this is linearization. And the question is also asking find to classify the critical point. So we have only one critical point. Let's try to classify it. And to classify it, we need to find the eigenvalue, right, of the Jacobian. But for the sake of time, let me find the eigenvalue using a tool. And I don't have enough space actually for eigenvalue, as you see over there. Okay. So that eigenvalues, so 0, 1, negative 1, and 1. Let's find eigenvalues. Okay, so eigenvalues are, eigenvalues are 1 plus or minus I root 3 over 2. So we have a complex number, right? Both eigenvalues are complex numbers. And if you end with positive real part, right? Real part is 1. That's why this is an unstable spiral. So all right. Okay, I hope it is clear. So this is the end of this section. If you have any questions, let me know, okay? All right. Let me stop video here.